Hello guys. So I was absent for nearly 3 months and it's time for me to make a tutorial. Uh, I know that I promised making it earlier, uh, but different things happened. I also gonna say that it's not the tutorial I used to make most of my time. It's gonna be the in-depth breakdown of the complex feature, as it has a lot of different intersections, not only in the blueprint logic, but with animations, particles, and UI. I'm gonna pay attention to only hard and most valuable parts of this feature, and I'm gonna omit some easy and obvious things. But for those who probably will struggle to replicate it step by step, I'm gonna place the sample project on my Patreon completely free for some limited time, let's say 1 month. This feature is designed mostly for the top-down game, but it can be changed for the third or first-person shooters. It has different intersections with the inventory and equipment system. For those of you who know me quite well, for some period of time I stick to the special inventory like Diablo or Path of Exile, but I decided to remake it to suit my game better. So this feature is also gonna be included in this kind of tutorial and the sample project. So you may also use this video as the one-on-one instruction how to use the feature itself for those of you who will get it. In this tutorial, we're gonna talk about the hit scan weapons. So for like aiming and dealing damage, we're gonna use the line trace. It's the common way it's like in a lot of games, and we're gonna use the projectile, the physical one, only for like the grenade launchers, the rocket launchers, maybe grenades and so on. But it's gonna be another in another video. Let's start. So first of all, we need to talk about the data assets. I'm actually a big fan of the using data table instead of data assets, so you can blame me. But still, for this feature, we need to make the following. So it's the two data structures, weapon data and weapon data visual, two enumeration, so simple list for the weapon type and the fire mode. We also need to make the data table from the main data structure, the weapon data. And I also have the float curve for the damage fall off. So to make it all, you just need to press right mouse button. For the enumeration and data structure, you need to select the blueprint. Here we have enumeration structure. And for the curve and data table, we need to go to the miscellaneous category, data table and a curve. So the design for this system is heavily inspired by Destiny game, as I'm a big fan of it, from like inventory, how the weapon fires, the UI stuff, how it reloads, how they use consumables, how they store them. So yep, now let's fill in the most necessary data. I probably said it already. So we start with the enumeration first. Weapon type, we have primary, special, and heavy. The primary is the one that's gonna use unlimited ammo, The special and heavy will have limited ammo, so we need to like shoot our enemies and pick up those ammo items, ammo crates. For the fire mode, here we have the single, burst, and full auto modes. Single is meant for like if I press my left mouse button, so I start to shoot, I'm only gonna fire one bullet. Burst means that I can fire several bullets at a time at a one press. Most of the time it's like 3 or 4 bullets in a row. And full auto means that if I press and hold my main key, I'm gonna like use all the ammo in the magazine. As for the, let's say, weapon data visual, here I store different particles for the like the muzzle, hit scan, impact, surface impact, and projectile trail. So once we start shooting our weapon, we need to have the muzzle flash that has the visual indicator that our weapon is like works. You also need to have the projectile trail so we can see the like the how this word is called, the vector, the trace, the direction where we are shooting. The hit scan impact, so it's the impact if our bullet hits our target, and the surface impact if we like shoot not in our enemy but maybe in the floor, in the building, in the bush, wherever that cannot emit the blood. So those are just the placeholders, but for different weapons we're gonna have different like those particles contains the dynamic data that we're gonna change for different type of weapon. As for the damage fall off, you may see that it's a simple curve from 0 to 1. So it means that, let's say we have the effective fire distance 500 units. So with each segment, like if the enemy is closer to us, it's gonna get the more impact, the more damage it will receive. But with the distance, the damage should diminish and completely completely dissolves. So it's gonna be 0. Well, like I only made this one, but for different weapon, like it only depends on you how you design your system. You should make different one. Now the main data structure, weapon data. Here we need to have the reference to our weapon type enumeration, fire mode enumeration. You have the burst length, so for each weapon, how many bullets in a row it can fire. Like this system is kinda ultimate, so we're gonna have only one base class, but all the different weapons with the different fire modes, different settings, gonna be inherited from this base class, and each weapon can be modified to become like the hand cannon, or maybe like the Uzi, or like the scout rifle, and so on. The damage, it's the raw number, which gonna change with the damage fall off curve. Fire distance, the effective range. So let's say, as I said earlier, 500 units. So on all of these lands, on all of this vector, the damage gonna be calculated and we have the impact, but over this distance no impact will occur. Precision, so how like how many bullets will hit our target in a point that we're gonna be aiming. Next, ammo capacity, it's the vector to because the x gonna be, let me like the x value is gonna be for the rounds or bullets in the magazine, and the last one is like what we have in the reserve. So let's say we have here as the basic 721, it means that we have 28 bullets. It's all 7 for the magazine, 21 for the reserve, so we can reload from it. RPM, so rounds per minute, so how many bullets we fire. Particles per shot, it means that if you talk about the shotgun, we fire a slug and it contains of the shrapnel, how many particles it will have. And each particle will have its own like damage. So it means if I shoot a target in a close range with the with the low precision, we have the big conus of the weapon spread, of the not weapon or damage spread. Some of those particles will not hit the target and the overall damage gonna be lower. The reload time and the data structure for our Niagara system. So that's how it actually looks like, the basic setup for every weapon. Primary single burst length, damage fall off, blah blah blah. And that's how my current weapon data table looks like. So like the Smart M1, it's the pistol. Type 2000, 2001, it's the scout rifle and auto rifle. No. Type 2000, type 2001, it's like the, we also have sort of the rarity of a weapon. So we have like common, uncommon, rare, legendary weapon, and those weapons differ with their stats. And yep, each quality, like each item of different quality should be registered here in this data table. And TS12, it's the shotgun. Well guys, I have waited to the next day so I have enough lighting inside my room. So hopefully my camera wouldn't stutter. So we continue and we need to make the base weapon class, so from which we're gonna inherit our children, our actual weapons. And as you can see, it's the simple actor, kind of, because at the top right corner here is the reference to the another class that I inherited, this one. And this one is also the child of the base interactable class. So as I told you earlier, this tutorial, this sort of feature is relies heavily on my previous tutorial that I made, and is designed for the top-down projection. So it means that for me to pick up an item, to store it and so on, I use the point and click interaction. So my point is that honestly, it really doesn't matter how you manage to make your weapon system. It can be simple overlap, so you overlap with your item, what type of item. It might be already the weapon class itself, not the interactable class, then the weapon class that's inherited from it. So how you switch weapon, it might be on your side, your design, but here I'm gonna just show how I did it myself and explain why I did it this particular way. And I highly recommend you to check up on those two videos so you can get the idea better, because they are also like in-depth tutorial and explanation on different parts of system that are included here in this weapon system. So the first one is the point and click interaction that I made a year ago. And the advanced special inventory. Yep, I know that I said that I remade it, but the idea, the functions, how the logic works, the whole process, the flow, is right up here. So let's go back to the tutorial. And here we need to, well, I guess we should just start with recreating the functions and the variables, because there are a lot of them, and the reason why I have them, like a lot of them, I'm gonna explain it. So we need to have the pass weapon db function, init weapon core, init weapon visuals for like our Niagara systems, two functions, fire weapon single and fire weapon auto for different firing for different firing modes, launch projectile, get muzzle transform, so we can apply the muzzle flash there and start line trace from it. Calculate aim offset for the animation stuff, like if we try to aim at some point on the level, it should change the y-axis rotation. So it's like from the aiming to, like from floor to the top. Calculate spread is for not only the shotgun style weapons but for everything. Simulate foliage interaction is for, like, you don't really need to recreate this one, it's just for me, as I have this sort of interaction system with the foliage that is based on the render target masking and changing the roll position offset of the mesh. Next, decode hit scan result. Yep, and I just need to check, so what inputs and outputs we need to define. So at the get muzzle transform, it should be output location rotation, so it's vector rotator, and some of those functions are pure functions, so I don't need to have the incoming and like the in and output pins. So calculate aim offset, the float for the aim offset, spread, simulate foliage interaction none, decode hit scan result, it's the hit result, distribute damage, so here we calculate the damage itself, init float damage data, draw floating damage, and reload weapon. So like init floating damage data and draw floating damage, I also have a tutorial on it that I produced 3 months ago. You may see it, it's the latest one here, like this one, the texture. So now we need to check on our variables. I have categories for each of them, because if I don't, it's kind of mess, because there are like a lot of them. So we need to have the weapon db, it's the data table raw handle, because we need some way to extract the data from the table, and once you create this variable, you should define the base data table right up here, and then once you like create the child inherit from this class, you just need to place the raw name for each of them, like I have it here. So weapons, let's say smart m1. Here I already have the data table by default, which comes from this default state, and I just need to select the raw here, so my weapon should know, like will know all the stats from it, like from this data table. Next one, magazine size, reserve ammo, current ammo, leftover ammo, damage base, damage calculated, so it's like the modified value once we have the damage full of curve influence on it. Next one, visuals, weapon attributes widget. Yep, we need to make 3 different widgets. Like the one for the reload progress bar, then one which contains the current and reserve ammo, and the one is like the container that holds up 2 different widget blueprints. So I also have the weapon anim blueprint. So each weapon has its own overlay animation blueprint. Like if you ever seen how the Lyra works, the Lyra sample project, it's based on the having different layers of animation applied in the one animation blueprint. So the point is that each weapon have its own style how to animate stuff. We also need have the montage to play, so it's the particular animation which is played once I start firing a gun. I also have floating damage material. It's for like the coming out stuff, like those numbers that we have in the scene. Floating damage text tint, it's linear color. The dimensions, so as you remember from my previous tutorial, I used Niagara to render those numbers, and I need to define the size of each quad, like the size of the sprite, and the floating damage offset. As for the VFX, we have the muzzle flash, hit scan impact, surface impact, projectile trail. They all are different Niagara system components. So we're gonna like come back here in a while. The first thing is to complete this, like breaking down this main blueprint. We also need to have states like is active for which weapon is in our hand, so we're gonna shoot it. Whether we are aiming, so it's for like in this particular system, in the top-down projection, we have a lot of different corner cases that we should deal with. So everything further in this tutorial, and is reloading. So like just an example, so you like when you fire a gun and you need to reload. So if you try to reload and you need to switch to another weapon, we need to check the condition whether we are trying to switch, and if we switch in the period once we are reloading, we should cancel the reload and start switching to another weapon, and so on and so forth. I also have timers, because yeah, for the full auto modes, here we're gonna use the timer with the retriggable delay, like sort of functionality. So we need to calculate the delay for each bullet which is fired, and so on. So the reload time base, reload time modified, aim location, projectile spread, it's also the vector. Particles per shoot is for shrapnel. Fire distance, precision, projectile travel distance, so it means like as I told you before, so once we start shooting, we have some particular distance over which we can deal the impact, deal the damage. And over this distance, we cannot do anything. So the fire mode, burst length, burst counter single, burst counter auto. So we use those variables to like check whether we are at the ends of the burst length, and if it's so, we need to reset the whole cycle. Also further in this tutorial, the weapon RPM, and from the hit scan result, hit scan like the boolean, whether we got hit or not, because it depends whether we're gonna apply or spawn the impact particle. impact point, impact direction. Hits can act, so we're gonna know whether we hit an actor and what to do with this actor, like to apply the damage to it and so. And the weapon type. So, yep. And also the point for having a lot of those variables, it's not just for like the caching values. Like if you take a look at the function parse weapon data, that's here I store the data structure, and the data structure for each weapon that is inherited from this base class has its own values. If I try to make the break of this data, I have a lot of different variables, and if I try to use this sort of logic where I just grab the weapon data structure, break it, or like split, which is all like the bad practice, like this, you have a lot of mess and you're using blueprints and you got a lot of spaghetti code. So that's why I have a lot of different variables just stored so my graph looks cleaner and tidy. Now we need to talk about, like, let's talk about the flow and fill in our functions with the functionality. So we should start with the event graph so you can understand the flow and is the place where all the logic is organized. On the event begin play, I have the parent called to my parent class, so the container base, which do the same back to the interactable base. Here I have the bind to the dispatch event in my interaction component, which will call the perform action custom event. This event is overridden in several places, so the logic for each item is different. And as I said earlier, you don't need to like follow up this part in case you have your own weapon system with the overlap events and so on. So next I have call to the parse weapon db, where I need to extract the data from my data table, store it to the data structure, and then have two more function calls. So we need weapon core. Here I have like I extract the data from the data struct and store it to variables. The difference is here, so the precision is the angle, like let's say 30 degrees, but it's calculated in the positive and negative bounds from -15 to 15. It's just the example. So I like to have it here calculated, not to do extra calculation every time, like if I fire a gun. So it just needs to be calculated once here, once the weapon class is initialized. And right up here, once the weapon class is initialized, I need some values so I can start modifying. So the magazine size go to the current ammo and reserve ammo go to the leftover ammo. So once I try to shoot and I need to reload, the current ammo and leftover ammo will be overridden, and the values will be different from the initialized stuff like the magazine size and the reserve ammo. And so as I said earlier, capacity X goes for the magazine size and the velocity Y to the reserve ammo. That's why I had the vector 2 here. We need weapon visuals, so we need to initialize our Niagara particle systems. And here I have some extra stuff. So for the reload function, I use the timeline right up here. So to modify it, I need to do the following calculation. So I divide 1 by reload time base, and it will modify the timeline. So I don't need to have like different timelines. It should be like the normalized value from 0 to 1 in the timeline. And this value will automatically change the speed how this timeline will gonna play. And here I create the weapon attributes widget. So they look like this. So as you can see, it's a container which contains two more different widgets that I told you earlier, the weapon ammo and the weapon reload. So we need to create 3 of them. So the weapon ammo contains of the border. It has the horizontal box which stores the text for the current ammo and the leftover ammo. Here I have the rich text, so I can modify the visual how my text looks in the game. And each particular column here defines the size, the font, the color, things, and so on. You may make it on your own, or you can just like use the default, since not the rich text but default text, and make your changes right up here. And for the weapon reload, it's the simple progress bar. What else? The weapon ammo blueprint here has the only one function, update ammo count. So we're gonna call it from our weapon base. Once we start shooting, we need to update this widget. So it should have the current ammo, leftover ammo, float inputs. This one is logic to organize the text, so the my widget updates on its particular behavior. So if the current ammo, let's say, equals 0, I need to use one tag. If it's not, I need to use another tag, blah blah blah. So the text and update the like the each text variable. And the reload one, here I have on the construct, I need to set percentage of my progress bar to 1. And just to like remove preview value that I have right up here, just for me to see how it looks. So by default it has like 0.6 on the event tick, and yeah, it may be done better, but it's just the temporal decision to make it on a tick, not on a timer, or maybe on a demand. From the progress bar, I check the percentage. Even if it's not equal 1, I need to fade it. So I need to like set render opacity smoothly. So for this one, I has the interpolation, and I can't use the timeline here because widget blueprint doesn't have the timelines in the blueprint. Like in the blueprint, maybe it can be exposed from the C++. I don't really know. For this, I get the current opacity. I use the world at delta seconds at the delta time. Target should be 0, and the interpolation speed is 3, so it's smoothly fades. But once I start reloading and it check this condition, it's gonna bring back my progress bar opacity back to 1 until this condition gonna fire again, like with the false statement. And update reload time, I also have this function which sets the percentage. So the reload time, I normalize the value because let's say it's going to be 3 seconds, but the percentage is from 0 to 1 range. So I use this one. This. And this function is also going to be called from the weapon class. For the weapon attributes widget, I just need to place the weapon ammo and the weapon reload widget, align it right up here, and it's just a matter of taste, so you should do it on your own. The graph is empty because I don't need to do anything right up here. And once the widget is created right up here, right, and I don't need to like make 2 other widgets because they are already being created if they are placed here in the hierarchy, like this and this. So we can close those one and continue. So we done this part, we done this part, pass weapon DB is explained. Let's continue. So Moving next, here you may see I do have subscriptions to the two event dispatches. So I subscribe to the on weapon equip and on weapon unequipped events that are called inside the equipment component. Custom events here are executed that are executed are ready to fire and ready to drop custom events. So I don't have implementation of the equipment component here, as I did it inside the parent class of the weapon base class. It's the container base, and on the event begin play, I get the reference to this component. The reason why I chose player controller to store the equipment component inside, so if I have like a vehicle and I need to share my inventory and equipment, I don't need to recreate it once I swap between those characters. And so what these events, or like these dispatch events do, so I call them once my weapon is switched or spawned. So if I have a weapon and I need to switch it, first of all I need to unequip my weapon and then equip another one, the current. Or even if I don't have any weapon at all, if I pick it up, I need to equip it. So those dispatcher calls are fired. And once they are fired, those two can be used. I also stored the reference to the skeletal mesh of my player pawn, because right up here I use play montage and I need the reference to the skeletal mesh to play particular montage. Yep, so if you remember that I told you, I have the animation layers, animation blueprint layers that define the general behavior, like how I move, run, aim with my weapon. So they are different animations, but play montage here like is the intersection inside this animation blueprint layer. So I need to blend between those animation things. Yeah, so that's why I have the reference to skeletal mesh. Also, event destroyed. It's a good practice to unsubscribe from all the events to handle with different corner cases, like I have two weapons, I need to drop one or to store it back to the inventory just in case. And if I don't unsubscribe from the ready to fire event, once I press fire, it probably will start firing from all weapons. So just remember, clear your subscriptions once you don't need them. Now, the custom event, ready to fire. It checks whether the weapon that is initialized is the one that I use already. And if it's so, it means that this weapon becomes active. I enable inputs on this weapon, so like the reload here and something else I don't. Yep, here we have the reload, and we also have the input events fire start and fire finish. So it means that I can call input events from this class. Then I need to link anim class layers, so the one that we created and extracted from the data table. And it means that the current weapon anim blueprint layer is gonna be the main one, and it will override the previous one. So let me just show you. So if I pick up this weapon and I start walking, it looks like this, and here how it runs. So you may see how it holds. But if I pick up, let's say, pistol, you may see how I walk and how I run. It's the different animation stuff. So it's the override for current active weapon. I also enable the widget that we created earlier to show up how many bullets I have, and if I start to reload, I also need to have this blueprint in my viewport, like this. So nothing in the top left, in the bottom left corner. I pick it up, I have it, I start firing, I'm reloading, and everything works fine. And I need to call the update ammo count function. So from the weapon attribute widget, I get the child widget that contains inside this master widget. And as I said, I need to update the ammo count once per weapon is initialized, so the weapon should know its current and leftover ammo. And once I'm firing it, I'm also gonna use this function, but in other place. I also need to set actor hidden. Unhidden, I'm sorry. As if I pick up an item, if I remember it correctly, why I do it, I'm not destroying all the weapons. They are attached to the character, and then if I switch, I'm just hide one weapon and unhide another one. And I set actor enable collision. So if I remember it correctly, I need to do this one, because without it, the attach simply won't work correctly. Ready to drop. I check if the owner of the weapon, the one that is attached to this, to the character, is valid. And if it's so, I need to, like, this one is called once I need to drop weapon or like to unequip it. I need to set it as not active. I need to disable input from it, unlink current animation blueprint layer. I should hide the weapon UI stuff. I should call fire finished, just in case if I was firing. I need to stop playing current anim montage and do the following stuff, like hide the weapon and disable collision, so it won't be overlapping with me and producing like any errors. Moving up next. So next one, the weapon inputs. So for this I have the input mapping context with assigned to input actions the fire and the weapon switch. So this one and this one. I'm using the enhanced input feature because it's kind of easy to control the input inside different places. So for the fire, I'm using the right mouse button, and for weapon switch, I'm using Y button. So to make this one, simply select right mouse button where you want to create those assets and select input. So context mapping and the input access. The implementation of the input mapping is inside my player controller, as far as I remember. Just let me check it. So player controller, yep, on the event begin play, I added as the one, and once my character is under the control of the player controller, everything begin to work. So this I can now close, and on started I'm calling fire started, and once it complete I'm calling fire finished events. There are also custom events that you may see right up here. Now let's talk about them. So the first one is to check whether we are firing or once we are on the reload, once our reload is in the progress. So it means if the weapon is active, so the one that we are holding in our hand, And if we are not reloading, we can start firing. But if we are in the reload state, we cannot produce like any fire. Next, we check whether we have any ammo, and if it's so, we can aim and we can shoot. This part is to update weapon notification. What it does? Well, yep. So it's the custom event which will show up or hide the widget that's is the service one, which says that whether we should reload or whether we are out of the ammo, depends on the situation. This event, let me show you. I also have the tutorial on this. So basically it's the function that's inside the blueprint function library, so it can be called from every place in your blueprint. So simply what it does, it checks whether I have the notification widget inside my player controller. Then, depending on the context and the type of the notification, it's gonna update notification with the particular message. The message is stored inside the map that is implemented here. So depending on the enumeration, like the no space, incorrect slot, reload, no ammo, I have those messages: not enough space, can't place it here, refill your magazine, no ammo left. So it looks like this. So if I pick up a shotgun, I start firing 1, 2, 3, 4, 5, 6. If I try to fire one more time, here you see refill your magazine. So I'm doing it one more time. 1, 2, 3, 4, 5, 6, and one more time, just to show you how it works. Sorry guys. One more time. And once I don't have any ammo at all, and if I try to shoot, it will say like no ammo left. Or if I yeah, something like this. As I remade my inventory, I cannot drop any item up here, I just can dissolve it. So you may find this tutorial on my YouTube, and we can continue. So also the conditions, right? So if the leftover ammo equals 0 and current ammo equals 0, it means no ammo, update your message. If it falls, I also check if my current ammo is 0, it means that I need to reload because I have something in the reserve. And if it's false, I don't need to show anything. So that's why once I start firing, I need to check this condition. Next, depending on the fire modes, I need to call two different functions: fire single one and fire full after. Let's see each of them. Basically, they are nearly the same because fire after is a timer which calls the fire weapon single just with sort of delay, and that's it. So fire weapon auto. We use set timer by function name and provide the fire weapon single, the name of this event, right up here. As for time, we got the weapon RPM and we divide 60 by this value. So we also need to set the timer to loop, and it's gonna call the fire weapon single every time once we are holding up our key with the delay. Delay is up here. We need to store our timer so we can then clean it up once we need it. And to, like, if this one is the delay between events, we need to fix the initial function call, because if we press it, it will wait the first delay and only then fire. But we need to fire right in the moment and then use the delay. So for this, I call fire weapon single just one time, and that's it. Now back to fire weapon single. So here are our conditions. If the current ammo isn't equal to 0, it means we can fire. As this one is triggered on the timer, we need to check this condition every time, not only one. We also need to check whether we are not reloading, and if it's so, we can continue with our logic. Next, we check on the fire mode. Yeah, if this condition fails, we should simply call fire finished this event, but we're gonna talk about this a little bit later. So if it's full auto, we go here. If it's not full auto, it means it might be burst or like a single fire single bullet. It's gonna be up here. We begin with the first one, so it's the not full auto, but it's the semi-auto. But the semi-auto can also be the bursts, like you press key one time and you have the series of 3 or 4 bullets in a row. Here we need to check the condition whether our current burst length that we have inside our data table, if it equals the counter of the burst. So if they are equal, it means that we need to reset the cycle. So we need to use fire finish to stop shooting, and then we are waiting for the next click on the key. So it won't be shooting until we redo this action. Until then, we continue to increase the counter and decrease the current ammo. Next, I have sequence, as you can see, just for better readability, not to have everything in a line. As it's the top-down projection, I have a function implemented inside the blueprint function library called getLocation under cursor, which basically stores the hit result location and use the visibility channel to check whether we are like hitting something. So I store it as the temporal variable up here. Then I use I need to change the direction at which I'm shooting. So it looks like this. So it's only my way how to implement it, and as like we can make the smooth transition between the character once it's trying to turn, like with the sidestep and so on, but I'm a fan sometimes like it's not that important for us to make those things. We are not making the AAA game, and sometimes simple is better than complex. So it's like this, 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 and this. I'm good with this one. So we need to use find look at rotation. We check the position of our character, we check the position of our aiming. Then we need to break the vector that we have and use the yaw rotation. So we don't need to use any roll or pitch. And we store it as the temporal target direction. Yep. Next one, we need, like, if we start shooting, we need to stop our movement immediately without any continuation, and we need to change the rotation of our character, like this. Next, we need to play fire animation. It's the custom event which gonna execute this logic. So play montage and something else. I'm also gonna explain it a little bit later. And we update the widget, the ammo counter. So we need to provide the current and the leftover ammo. And that's it. But if we are on the full auto mode also can be divided whether we are using the burst or not. If the burst length is 1, it means that we are firing full auto but 1 bullet at a time. In Destiny you have, oh maybe in the other games too, there are like the how they call the pulse rifles, and they can be with the full auto mode, so they fire 3 bullets in a row, a little delay, and the cycle continues. So, but you don't need to pull the trigger, or like to keep your and you don't need to press your mouse button or like any key one more time. So just hold it and that's it. So if the burst length is 1, we do the following. We update burst counter single and do everything that we already done. That's it. But if it's not, if the burst length is higher than 1, so we need also to check whether our counter of the auto, so the single one is the burst for not full auto mode, for the semi auto mode, and the burst counter auto is for the full auto mode. So we need to check whether the magazine size is equal our burst counter auto. The magazine size, like it's a little trick here. So we are firing until our magazine, our initial bullet in the magazine isn't empty. This one we defined in the beginning, like once the weapon is initialized. So let's say we have 12 bullets in our magazine by default, and we start shooting with the full auto with the burst. We will continue shooting until our magazine is empty. So if it's empty, we need to call fire finished. But if it's not, we also need to check whether the burst length here isn't equal the burst counter single. If it's not the same, we need to increase the burst counter auto and do the same right up here. And if it's false, we need to call another function which is called provide delay for auto with burst. This one. So this event will do the same. Will do the following: we fire 3 bullets in a row, we wait period of time, then we start firing 3 bullets in a row, and so on and so on. Hopefully you understand this. Check everything one more time. Think about it, because it might not be obvious for the first time. Now back to our event graph, and we can continue. So the fire finished event. So fire finished event. Depending on the fire mode, we need to do several things. If it's a single one, so the logic is kind of pretty much simple. We just need to clear the fire weapon timer, because this event can be used in the auto mode. So we need to clear the timer, we need to stop shooting, and we need to drop our, like reset the counter to enable burst again. So the burst counter single, it's 0, and the same goes for the burst counter auto. If it's a burst, then we need to check whether burst counter single is equal the burst length. So if it's the same, we do the following up. Like all our actions, all our conditions here are gonna set in like different variables, but everything will go to this point. So if it's not, it means that the burst counter single isn't equal our burst length. We can produce more bullets. Then we need to check like if the current ammo equals 0. If it's equal 0, we're gonna do the same. If it's not, we need to check whether we are reloading, and so on and so forth. And for the full auto, we check whether the burst length equal 1, because like it's the full auto but without burst and with the burst. If it's 1, do the same. If it's not, stop shooting and continue if it was the simple burst, like all this. Well, 5 finished. Okay, now let's talk about provide delay for auto with burst. That's we got at the fire function. So we have 3 bullets in a row. Then we need to provide the delay, but we also need to continue with our full auto mode. For this, we need to clear our timer, make a small delay. I didn't make this one inside the data table because I don't really know whether you need so much detailed weapon stats, because honestly, if it like 0.1 or 0.2, 0.3, we are not making like the real-time firing game, so a small delay between the burst, I guess it's enough in like most of the time. Then we need to set burst counter single 0, so we can continue with the logic here, and like we should in 1, 2, 3 clear. Then we need to check what increase the counter 1, 2, 3 until those like the burst counter and the burst counter single gonna be the same. And then we also execute fire weapon auto, and this one will trigger the event one more time. So it's like we have event on the timer, we stop it, we wait it, and we reactivate it, and it's in a cycle until we are holding our key. That's it. And if we are not shooting, we just need to call fire finish to bring back all our basic variables to their initial state. For the reload here, I didn't make it inside the like actual action. I just use it as the simple hard-coded shortcut. Just a temporal solution, because I was developing this feature for quite a while. So once we are reloading, if the key is pressed, I need to check whether leftover ammo, or like if we have it actually. If we have it, we need to check whether the current ammo isn't equal our magazine size, because like we have leftover ammo, but we don't need to spare any ammo at all if we have like the full magazine size. So what's the point of reloading? If we are not reloading, like if I try to press reload several times, if I'm already in the reload state, I don't need to re-reload myself, and so on. And I also need to check whether our weapon is active. If everything is okay, we set reloading to be true. Here I have the simple timeline with the following. Yep, I have sort of the smooth easing out state, but it can be simply linear. So it's from 0 to 1 range. We store the reload alpha as the reference, so I can use it here. I also need to check whether my weapon is active, because while I'm reloading, I can switch my weapon. I don't need to reload it. And if it's active, I'm updating the reload time, which actually updates the progress bar of our widget. Like these functions I showed you for this little thing, this progress bar. And if it's not active, we need to stop our timeline. And we need to set is reloading back to false condition. And once we have the timeline, like if it's completed, we need to reload the weapon. Yep, it's another function that we have here at the ends. We're gonna talk about it just soon. And we need to set is reloading back to false, so we can reload once all those conditions gonna be true again. As for the reload weapon, we do the following. Yep, I also have few local variables, or actually one. Yep. Well, the magazine size, subtract the current ammo, it's the reload portion, how many bullets we need to refill. Next we need to update the current ammo that we have after we reload it. So it's the situation like you fire several bullets, you have not full magazine, and you need to reload it, and you reload from reserve, but reserve is decreased. You don't spare any ammo at all. Everything is calculated, but it can be situations like you have maybe 4 in the reserve, and the full reserve stack should be, let's say, 7 maybe. And you need to transfer those 4 to the current ammo and clean up the leftover. So for this, we need to store this like the portion, so that we can reload not only, yeah, not the full size, not only the full size, but the portions of it. I'm so tired. So for the current ammo plus leftover ammo or temporary reload portion depends on the following condition, where the leftover ammo that we have is less than the reload portion. So depends on this condition, we're gonna set our current ammo with the reload portion or the full size of the magazine. And for the leftover ammo, here we do the following: leftover ammo, subtract the reload portion, and we check, like if we have it 0, we cannot reload at all, and we go with the 0 leftover, so that's it, we need to find new ammo. And if it's not, we're gonna store as much as we left. And we also need to update the widget, the ammo count widget. That's it. I talked about this one. Here on the event graph, the only thing left is the play fire animation. So in play fire animation, we have the play montage. So we provide our skeletal mesh reference and the montage that we get from our data table. I also have a little trick here. So as you can see, once play montage fires, I have a retrievable delay with 1 second, and then I need to stop animation and disable aiming, like set it to false. I have the reason for this. So if I shoot a target, then just for the better immersion and the visual part of it, like for person eye and so on, the player should keep his hands at the target, so aiming, for some short period of time, and only then, if it was not fired again, like the weapon, the character should put down his hands and stop aiming. If you play montage inside the animation blueprint cycle without any transitions and any fancy stuff, it simply will like blend out to the main like pipeline of the animation blueprint. So let me show how it look without any changes. So if I take up my pistol, I fire, and he pulled his hands down immediately. One more time, one more time, one more time. And it simply doesn't look normal. So for this, this little trick is done. So you implement this logic, right? Let's say I have the duration of 1.5 for just longer delay. And inside each montage, yep, it should be done for each montage. Here, the left top side, you may see that I have enable auto blend out checkbox deselected here and here. So once I start firing, and if my fire is delayed, like I don't know whether I want to fire immediately or not, my character will still be aiming. And only after this period of time, 1.5 seconds, he'll put his hand down. That's it. And I also have notification, and this notification, I made it inside one montage and just copy paste in all of them, like this, but it has different start point. So once this notification fires, I am actually firing. So I'm shooting at the target, and the main logic of dealing damage begins. So launch projectile. The first function is calculate aim offset. We need this one to calculate the pitch angle at which we need to blend our upper body inside the animation blueprint. So our lower body will stay the same, but the lower body, our spine, hands, head, and everything will be using the animation montage part. So it's like when you want to aim at like the top or at the bottom. For this, we need to do the following. We also here we also calculate the aim location. It's like the position at which we need to stop tracing. So the function get muzzle transform is also made inside this blueprint. All my weapons have the socket, and I need to have the location rotation of this socket. So as an example, this rifle, this red guy is the socket. And it's the start position for our line trace and emitting our Niagara particles of muzzle flash. This function is pure, so we need to calculate the unit direction and multiply by the fire distance, so we know the effective fire distance from our start end to the end position. And here we add it to the begin location. So this one is our end location. As for the aim offset, we use aim location and get muzzle transform. We find look at the rotation, so we will know, and we need to inverse it. So it means if I push my mouse to the top, it should go up, not in opposite direction. Next comes sequences. Yep. So once the launch projectile is fired, we need to produce the muzzle flash. It doesn't really depend on whether we are making any damage or not. So I use muzzle flash system. For the location rotation, we use the get muzzle transform. Everything is like understandable. Nothing fancy. Next, we need to iterate, because as I said earlier, we can produce different particles per shot. So it might be shrapnel, or it might be a single bullet. So each particle, each piece of the shrapnel should have its own spread, its own damage and direction. I just use the first index as 1, so I don't need to like subtract from this -1 and so on. Particles per shot by default are float, but I need to truncate it because we can iterate only with the integer. And then we need to call these functions: calculate spread and simulate foliage interaction. This part I'm gonna omit because I'm using this to fake the movement of my foliage once I'm hitting it with the bullet. So calculate spread. If you remember, we have precision, and the precision here is divided by 2, so I can use this one and multiply it by -1 to get the full range from minus to positive bounds. And I use the random floating range 3 times, because if I use the only one here, it will return me the same results like this and this. So the one calculation for roll, for pitch, and for yaw. So it's like the cone, right? And everything to the aim location. So I start with the one position. It's not a cone. Yeah, well, let's call it cone. Something like this. And we're gonna store it and call it projectile spread. So for how many particles in a bullet we have, so many projectile spread vectors we're gonna get. Next sequence, we're gonna do the line trace, and we do line trace by channel. As you can see, the line trace channel is set to hit scan. It's the custom channel with the custom response. So we go to the project settings, we go to the collision, I guess. Yep. Here we add the new trace channel. It's a hit scan, and the default response is block. Next, we need to use trace complex, as like in my game I do have a lot of not simplified collision but the complex one. So for the start point we go with the muzzle location, and the end is the projectile spread. And we need to get our attached parent actor, so we cannot collide with the character once we fire in. So we need to make it as the ignore actor. And attached parent actor is obviously our character. And then another function, the called hit scan result. So basically it's just to not have all of this spaghetti here, just the way to organize everything. So we simply break the hit result and store hit scan, hit boolean type, projectile travel distance, and it's at time. So yep, it's like the normalized version of if the bullet was, if the lifetime of a line trace is small, it's gonna have the most impact. If it's big, the small impact. We also store the impact point normal. We use rotation from x vector, so it means if we hit a target, the particle should be facing the opposite direction, because we're gonna use the same particle. And we also store the hit actor, because we're gonna make a function call to the hit scan actor, so it's gonna change the health of an actor. Once we get this done, we need to spawn another Niagara system, and it's gonna be the trail. This trail has some dynamic variable, so I'm gonna show it a little bit later in case you need it. And we also need to store it here as the reference, because I'm using it right up here. And depending on the result, whether we hit or not, we should spawn the not only trail end at different positions, but the impact point also. Then, whether we hit or not actor, the impact point going to the Niagara system trail ends if the result is true, and we need to spawn the impact. If it's not, the trail end point of this is gonna be the projectile spread. So it means we're not gonna produce, let me just explain it maybe with the paint. So we have a wall, we have a shotgun. If we hit a target, it's gonna drop this part and only make visible this part of trail, right? But if it's gonna be like this, we don't need to, like, we need to show the whole distance, the whole trail like this, because it was not blocked with the wall. And next one, we check whether hit actor is valid. So it means that we like hit enemy. And if we can cast it to pawn, it means that we can distribute damage and do stuff that I already showed in the tutorial about the floating damage numbers. But if we fail to cast to the pawn, it means we hit on a surface. Then we produce another sort of impact Niagara system. And this part is, I'm gonna omit it because this part is for making impact points using render targets on the water, on the surface, on the foliage, and so on. Like, let me show you. Like, we have the weather here. Sorry, the weather. We're gonna say it's gonna be winter. We're gonna play yes, and we need to check whether I have it enabled or not. Let me check. I'm working, not. I forget to do something what. So I found the place where I switched off. Now, yep, we walk, we have the marks, and we start shooting, and those marks are from our render target, from our particles. Just like this. Well, yep, now let's talk about the like init float damage. I'm gonna emit, draw floating damage also gonna emit. It's not necessary for this part. We need to check the distribute damage function. Let me check calculate spread. It was simulate, nope, decode, distribute, yep. The last function inside the base weapon class. So we need to get travel distance. It's the, if you remember, it's a time of a line trace, how it lasted. And they use get float value from our damage fall off curve to know exactly what multiplier we're gonna apply on our damage, our base damage. We also need to make it -1 because we're gonna, like in my system, once I'm applying damage, I'm updating the health. The health can be like the positive or negative. So that's why here I multiply by -1. So once I update the health, it's gonna be negative. I also need to round it because basically it's better for UI and for like I don't need to have those floating numbers. Just the raw impact. So I store it as the damage calculated, then apply damage. It's like the global dispatcher. It will tell how much damage I got, and then I can do different stuff. For instance, in my NPC, let me check it. So blueprint, common. Don't remember where I placed it. NPC base class. So event any damage. If it's if this event is called, I have a timer which says show me the health bar of my character, and once this event is triggered, I'm switching it to the battle state, and yep, I can like what I do. Actually, this it's gonna be expanded, so the NPC gonna start the fire, like it can also start firing at you and so on, but I have not implemented it yet. And we also have the function call update health. I made the tutorial on a health system. It's called the Bloodborne health system. You may check it. So it's the global function library event which simply update the health. Check it on the YouTube and it's great. So guys, now let's try briefly speak about the animation stuff. So here I have my animation blueprint base. On the begin play, I need to have the reference for my character and to my equipment components, so I can use them later. At the update animation event which is fired every frame. I need to check whether I have my current weapon, if it's valid, so I can use that function that we created earlier, calculate aim offset, and store it as the previous aim offset. We need this one to make the smooth transitions between our aiming state and, like, if we're not aiming and try to move and so. So those transitions gonna be fine. What else? I also have the get weapon state function that I've implemented inside the function library. So it checks whether my equipment component has the current weapon, and if it's valid, I need to get those states that we change during our gameplay, whether we are aiming, shooting, or reloading, and we just return it. It's the pure function because we don't need to set anything here. So depending on the data that we store, we need to update our offset. So if we are shooting, our previous offset that we have from our weapon becomes our current offset. If it's not, and we check whether we are aiming, we're gonna blend between our aim offset. So how this one will say how smoothly we will go from our aiming to our our initial state, which is updated inside the anim graph. So here I have the base locomotion, the idle run state, which you may find in a lot of different tutorials. I'm also not going to explain about how the layer system works. I'm just gonna show how it's done here without a lot of different explanations. I have the animation layer interface. I guess it's called like this, layer interface. Yep, with the armed locomotion event. So we also use it, like everything here, stored as the locomotion with weapon. It's the cache post. We have the default slot for our blending stuff for the different montages, and the default slot here is for blending between the weapon the weapon actions, like whether we are aiming or shooting. And here I have another slot which is called common actions, so that we can use another montages even if we are firing. So it's a little bit complex, but I guess if you check it yourself, you understand it. So next we need to use the blend pose by bool, and the bool is aiming. Whether we are aiming, we use the cache pose locomotion when shooting, whether it's not, locomotion with weapon. So whether we are aiming like this, or whether we're just walking around with our weapon. And we store everything to another one. Cache version is the base locomotion. Next we need to use transform bone. We use aim offset as the roll axis, and here we define the top right corner, the bone from which we're gonna blend between our default state to the montage. So, like, our lower body will stay the same, but our upper body will have the parts of the aiming animation. And something like this. What else? Yep, each animation layer has the override function of the armed locomotion, like this, and this. So here we provide the blend pose with the velocity, and each blend pose has its own unique style, as I showed you earlier. So if we walk with if we run with the pistol, it's something like this. But if we take up the, how it called, the rifle, we have another one. The hands is different. We change. And that's it. It's kind of easy and the animation layers are great. What else? So the interesting here, it's also going to be sort of the brief breakdown, is the equipment system that I made. So it's the component which is on the player controller. I store it there. Here you can see the input action, which is used for the weapon switch. And I need to store the triggered second so I can change not only between the primary and special weapon, but with it's also inspired with the destiny. If I hold it more than particular time, I can switch the weapon to the heavy weapon. It might be the grenade launcher, the sword, or like the rocket launcher, whatever. The logic's kind of simple. We check the condition, and if it's so, we store the boolean called switch to heavy triggered. Then we need to like check on the following condition. If the trigger is true and we can switch weapon to heavy, it's the function that I also created here, which looks like this. So we check whether the last active heavy weapon is valid. If it's so, it's true. If it's not, it's false. Yep, I store every reference to each of weapon type. So I have the current primary, current special, current heavy weapon. We need to do once because this check is done like on the, it's not like the longer I'm holding up the key, so it's executed every frame. Okay, so I need to call do once and use the function called weapon switch. Here I decide the index of which weapon should I equip. So 0 is for the primary, 1 for the special, and 2 for the heavy, as you can see right up here. Also, once I'm switching up my weapon, I need to unequip the current one, and then select the one that I have in my equipment to be the new one. So then I call another dispatcher on weapon equipped. What else? If this action is completed, you also check the following condition. So if it's triggered, if this one is holding up, but if it's completed, so it means that I pressed the key and I'm not holding it up, it's just the like click or press. I'm gonna switch the weapon between those that are available. So basically it's the following. If it's primary, index 1, if it's special, index 0, and if it's heavy, index 0. It just like the behavior from which weapon to which I'm gonna change. So whether it's primary to special or special to primary, or if I'm holding up, it's primary to heavy or heavy to primary. So how everything works also. If you remember, I'm using the point and click interaction. Let me just show you the blueprint, the parent blueprint of my weapon base. It's interaction, container base. Here you can see that once event perform action is called, then from the equipment component I try to call a function try pick and equip. And if it's so, I am equipping it based on this the condition, and I'm gonna destroy the actor that is on the scene, right, in the level. This function do the following. It check whether I can store it, the slot, like if the slot is empty or it's occupied, or I cannot store it at all, so it's going to be none. And the incoming item also says at which slot it should be equipped. And based on those conditions that we are calculating here at the can equip or store, like this, we define whether we are equipping item or we are storing it inside our inventory. I'm not gonna cover it all. Probably I'll make another tutorial, also the in-depth breakdown of the equipment and inventory system, just for you to understand the idea how it works. So the equipment component also contains the 3 array. Each array has the length of 9, so I store 9 elements of primary, special, and heavy weapon. Also, like, it's based on the destiny. So as you can see, this 9 slots, and the 10th one is the current active weapon or equipment, like, if just in case if I need to have the armor. So like this. You're also gonna get this one as the bonus content. So the last one is talk about particles. I have 4 base emitters and Niagara system that's we store inside the data table. They are like all derived from or using these emitters as the base. So the default settings are up here, and each system for each particular weapon has slightly different stats. So like I have the impact base, which looks like this, right? And the hit scan impact, there are 3 different systems which have like the same emitter, but it has different settings inside the initialized particle, like this one and this one. Sprite render is the same. Actually, here is just the size. It's not too fancy, and this solution suits kinda well. Maybe you need to do some extra stuff, so you can like place inside the logic of the projectile launch some new particles, some new system for smokes, or like for mesh particles to have, in case you heat up the concrete, some surface. So nothing fancy at all, except one thing, that's the trail base here. As this one is the simple emitter inside the Niagara system that uses it, we need to define the user attribute, which is called trail end. So simply press plus button, select vector, like this one. Then in the beam emitter setup, here just need to define the user attribute, and that's it. So then you can set it up inside the blueprint where we have it. Here. So set Niagara variable position, in each case different position. So guys, I guess it's time to finish here, and the equipment and inventory system is gonna be another tutorial. So I hope you like my breakdown. So the link to the sample project is under this video, so you can follow up there and get this one completely free for 1 month. And just in case if you want to support monetarily, you can buy a subscription. There are 3 levels, and the one is simple tip, it has no benefits. It's just your way to say me thank you. Please subscribe to my channel, leave your feedback, and see you soon, guys.